Hi, hello. So today I wanted to give more update on the XDP DDoS protection on the Loongson Mini PC. So let me show you the setup here. Again, this is a mini PC, Loongson Mini PC. And this is the green cable. That is the green network connected to my another backend server here, like that one, green cable to the backend server. Okay, so as a web server, and this red cable connected to my old router. So that is for the internet connection. And yeah, so this is the setup. And also my this is my Mac workstation to manage the mini PC router firewall. Okay, so I'm going to demonstrate DDoS a SYN flood attack. I mean, not a real SYN flood attack, just a simple SYN flood test to see if the mini PC can do DDoS protection. So again, I just write a web UI to enable the DDoS protection. So here is a manual. Anyway, let's see some command line first. So here, this is my mini PC. I SSH logged in Loongfire, and let's show some current program, XDP program here. So again, this is the XDP DDoS program placeholder that has the MIP ID 32 associated with it. So what MIP ID is the BPF or tail core program map. Let's show a map here. BPF to a map. And here, that is see the map ID 32 with the DDoS programs map. So that's the BPF tailcore program map placeholder for the XDP TCP DDoS or UDP DDoS protection. So we can again dump the map, name DDoS. So right now there is no, so it's 0 element. So there is no XDP TCP DDoS program loaded and attached to the map. So there's no protection, right? And so now we can go to the UI, and let's look at our current firewall. So here is the firewall. So this guy is, I wanted to show you this firewall rule. Right now, so it's basically a port forward firewall port forward services. So when the client sends a web request, this firewall will do the destination NAT address translation to forward the web request to the back-end server on the green network. On the green network and the server I just showed you. So this is the back-end server IP address. And the port is port 80. And so here we check use the XDP SYN proxy acceleration. So this is to set up the IP table rules for the XDP DDoS protection. I can show you the IP table rules here. For example, IP tables, save, group port 80. So from the web UI, it will actually set up IP table rule like this. So you can see there is a XDP SYN proxy IP table rule chain, and on the red 0 interface with destination port 80, with if it's a SYN packet, a jump to the collection tracking with no track. So this is the one. This is the IP table rule required for XDP TCP DDoS protection acceleration. So another one, this is in the raw table, in the raw, yeah. So this is another XDP SYN proxy. This is in the input chain of the filter table. See here with destination port 80, jump to SYN proxy with some TCP timestamp window scale MSS setting. So that's the IP table rule required for XDP TCP DDoS protection. Okay, so I can show you if I disable this, if I uncheck this setting, like no XDP SYN proxy acceleration. Let's uncheck this and see what's the IP table rule look like. So let's update, and then we need to apply changes. Okay, so now let's look at the IP table rule setup again. See, now there is no XDP SYN proxy IP table rule. It's just the normal port forwarding IP table rule. Okay. So let's enable this, edit this firewall rule. Enable this again, update, apply changes, and then let's look at the IP table rule again. So the XDP SYN proxy IP table rule is added back. Okay, so that's how you verify if the IP table rule is set up properly for the backend server. Okay, so now we can do a simple test from the client, from this iMac client, to send the HTTP request to the firewall internet IP address, the red interface IP address. Let's show you here. So in our system here, so this is our internet site, internet facing IP address, and this Okay. And this is our green network, internal network IP address range. Okay. So now we're going to send from the workstation, we're going to send a HTTP request to the internet side facing IP address, and it will do port forward to the backend server on the green network. Let's see if it works. Let's run the curl in a loop. Okay, so we have a web server response, right? Nginx server response. Okay, so see the IP address is the internet side IP address. So this is still, there's no, even though we have the IP, even though we have the, it's here, we have the XDP SYN proxy IP table rule set up, but still there's no XDP acceleration. Why? Because if we go to IP file menu, XDP TCP DDoS, because we have not enabled the XDP TCP DDoS protection here, we have not actually loaded the XDP TCP DDoS program, right? So we only have a placeholder. There's no XDP SYN cookie program loaded. So now let's load it again. Now let's enable this. Again, it's in IP file XDP TCP DDoS. Enable this TCP DDoS protection. We also needed to specify what TCP port we want the protection. We want to do port 80. So now we have this. We click save. So now it's saved. Let's look at it. If we have a XDP program loaded. So now you see there is a SYN cookie XDP program loaded, and now we can run BPF tool map dump name program XDP DDoS programs BPF map. So we can see here the key 0 has value which is pointed to this SYN cookie XDP program. Okay, so this XDP SYN cookie program, that's the actual XDP program to do the TCP SYN flood protection, and it has a 2 map associated, map 42, map 41. We can look at the map. Map 41, map 42. So this is the map ID 41, map ID 42. Map 42 is the allowed ports. That's the TCP port we want the protection. So we can dump this map and just check if the TCP port 80 has been inserted in the map port, allowed port. So this is so we can see here key 0 has value TCP port 80 that is inserted to the allowed ports. Okay, so this is one map. Another map 41 is the values. That's the number of SYN flood counter that the XDP program processed. So we can dump the value here, values map. So right now there is, we look at this one, this is 75. It has dropped 75 SYN flood. So, okay, so we will run a test and see if it's if the protection is actually in effect. Again, we have two client SSH session window open. So this window, we're going to send a normal curl request in a while loop every 1 second. So once I start this loop, we should see the Nginx web server response from the backend server. Okay. So yeah, there is so we always see this web server response. Now if we go to this SSH session window from the client, we start a SYN flood attack. This is not actual real SYN flood attack because I don't want to flood my local network. And this is, so I started. See, it's like not real fast SYN flood, but it's just kind of a test. Now let's look at our Loongfire, and then we should see this value increase, right? Because that's the XDP program processing the SYN flood. See, it's increasing 161. We can use this. Watch this increase. Okay, right? And our another workstation, we can stop it and then run it again. So it's working. Normal request is working, and this SYN flood is attacking. The number is increased. Okay, so it is working, right? Another way to verify this is we can run TCP down on the. So let's first stop this normal request. And another way to verify if this is working, we can run TCP down on the red interface 0 with port 80. We still keep the SYN flood packet, right? So we will check if we have the SYN packet from the TCP down on the red 0 interface. See here, we do not see SYN packet from the TCP down. The reason is that the XDP program is triggered from the network driver. So it is before TCP down that is using AF packet to capture the network packet. So it happens later after the XDP program processing packet. That's the reason we do not see the SYN packet from for the SYN flood attack, because the packet is already dropped by the XDP program. But if we start the normal request, we should see this packet from the TCP down. See here, and it is has that's the HTTP request. Yeah, no, that's the server response from the backend server, and with web content, right? So this is another way to verify it. Okay, so yeah, that's I want to show you today for a simple demonstration for a real SYN flood attack. I mean, not a truly real. Next time I'm going to run a maybe packet generator to do a real SYN flood, and this is just another demonstration. Thanks for watching.